Okay, now we're nearing the conclusion of my conclusion. I just described to you how a roof collapse, the actual entire surface falling into the magma chamber, will cause an eruption. Now, what I believe is it's a partial roof collapse. Let me explain. So we have our magma chamber again, and we have the surface with our lake. There's our little lake. As this dome's water comes in, hits. Like I said, I was wrong. It doesn't come down and hit the magma and then force its way in and create a pocket. That's wrong. What it does instead is it starts traveling back up. And this is getting wider all the time. As it's pushing more sediment through, it's eroding the ground, and it's getting wider and wider. So this is getting more intense all the time. As the water is trying to find its way up through the ground, it starts to do exactly what the geyser does. It starts to move through the cracks. Like, you have to understand that, I'll just put it underneath here for now. The mantle itself is kind of like bricks. There are these long forming bricks. Mostly overlapped. Anyways, the water will find its way up through any of these cracks, any way it can. And so what happens, at the bottom here, is as it finds its way up through the cracks, it starts, when it encounters blockages and it's not getting out, it starts to create chambers. Okay, I'll do this a little larger so you can see it. And we'll put this, hope you can see that. So as the water rises up through the cracks, it starts to circulate and erode. And what this will do is eventually create big pockets of gas. Because it's pushing the water back up, the gas is trapped, any water coming in, any gas coming in, it releases its gas, and then the water is pushed back up. What happens after this gets very intense, sorry, a lot of drawing to this. You have your magma chamber here, so the water is coming in from over here, hitting it, it's being sprung back up, and it's finding its way out all over the place. What happens is it starts creating big pockets. Now this could be one large pocket or several pockets. And because the ground is separated into layers, what can happen is there's a pocket of gas between the magma chamber and the surface. And what happens is you don't have a roof collapse, not a total one, but a partial one. And that's the key, that this chunk right here loosens up enough from the pressure inside of here, the simple pressure, like I said before, just like a regular roof collapse. But now this structure isn't even attached to the surface because it's been eroded in the middle. And so all of a sudden the lower chunk, because it's got fractures along the side, this lower chunk falls in. Now this leaves gas already here. The gas is already here, it's been accumulating. Now you have a large pocket of gas, and now your magma chamber is coming up. More water is falling, that should be blue. More water is coming in. And I know this is getting scribbly. Quite simply, as the water comes in, the magma chamber goes up, and you have doming, and eventually the gas mixture right here will ignite. Ba-boom. So I'm really sorry about the diagrams. As I said, I would love for somebody to animate it for me. I don't know how, I'm brand new on the computer. And I'll come back and I'll explain one more feature of the Snake River Valley in Yellowstone and how they are able to calculate past eruptions because it leaves evidence. Just like I stated that the bays, Hudson Bay, PEI, the Gulf of St. Lawrence, the Gulf of Mexico are all calderas. They're huge holes. Also the Great Lakes. So come back and I'll give you the evidence of that.